Let's try the next problem. It says that the heavier block in an Atwood machine has a mass twice that of a lighter one. That means there is an Atwood machine. So we should first make an attempt to draw an Atwood machine. So this is an Atwood machine, and machine will have two ends. It talks about a heavier block and a lighter block. So heavier block will be always downward, and a lighter block will be always up there somewhere. It's a heavier block has a mass of twice that of the lighter one. So let us take this mass is m. So mass is 2m, obviously. The tension in the string is 16 Newton. So the tension in the string is already given 16 Newton. Obviously, the tension in this string is also 16 Newton. There is no doubt in that. The question is, the system is set to motion. Find the decrease in the gravitational potential. Okay, we shall do that. Potential energy during the first second after the system is released. So there is something about the motion or the displacement. Since they want a gravitational potential energy, and gravitational potential energy, no, it is mgh, right? Gravitational potential energy, we know. Normally, we indicate by U is equal to mgh. M is known, given, G is everybody knows, H is a displacement, vertical displacement. That means we have to find out the vertical displacement. That is the clue. Okay? Now, let us consider the bigger mass. Consider the bigger mass first. From the bigger mass, what do we get? It is going downward with an acceleration, let us say A. This is going upward with an acceleration, the same acceleration A. Now, if we consider the bigger mass, then what is the net downward force is mg. How do we write the force equations? We first see which direction is the acceleration. Then we write what is the net force in that direction of the acceleration. In that direction of the acceleration, downward is 2 mg minus there is the upward force of 16 Newton. Right? And this is equal to, force is equal to mass into acceleration. This is equal to 2m into acceleration A. Right? So 2mg minus 16 equal to 2ma. From here, we can easily write 2 minus 2ma is equal to 16. This is one equation. Let us say this is one equation. Similarly, from the smaller mass, the smaller mass, what do you get? Here you get, here the acceleration is upward. So what is the net upward force? 16 Newton minus mg. So here you get 16 minus mg is equal to mass into upward acceleration A, right? So from here we get mg plus ma, mg plus ma equal to 16, right? So now we have two equations A and B. From these two equations, you can always write that. Okay, now let us do answer. This is 2mg. So let's write it this way. Equation A, the symbolic way of writing. In your actual examination, you may have to write in a different way. A plus, we write A plus 2 into B. This is a symbolic way of writing for your homework. A is 2mg minus 2ma plus 2 into D plus 2mg plus 2ma is equal to A is 16 plus this is 32. Okay. From here, we get minus 2ma plus 2ma gets cancelled. So 4mg is equal to 16 plus 32 is equal to 48. So we get here 4mg is equal. Now put this value of mg in any equation. Any equation. Let us say we put this value in equation D. From equation D, what we get? mg plus ma is 16. So 4mg plus 4ma is equal to 64. Sorry, this is mg plus ma is from here we are multiplying it by 4 is 64, right? So from here we already got the value of 4mg as 48. So 48 plus 4ma equal to 64. From here we get 4ma is equal to 4 minus 48 is 16. From here, what do we get? We get the value of acceleration A. Acceleration A is now 16 divided by 4m, right? Acceleration A is 16 by 4m. So A is equal to 16 by 4a, 16 by 4m is equal to 4 by m. So A is equal to 4 by A. Okay. Now, knowing this value of m, A is equal to 4 by m, now we can find out the displacement, vertical displacement in first 1 second. We use the kinetic equation, S equal to UT plus half FT square. So remembering this equation, S equal to UT plus half AT square. Using this equation, S equal to initial velocity was 0, so it is half. Acceleration is known 4 by m. 4 by m. T square is said 1 second, so it is 1. So it is equal to 2 by m meter. So S is 2 by m. We write once again, S is equal to 2 by m. S is equal to 2 by m. Now we have S equal to 2 by m. That means this bigger block goes down by a distance of 2 by n. The smaller block goes up by a distance of 2 by m. Okay. Now, bigger block loses its potential energy, and the smaller block gains its potential energy because bigger block goes down. So I should say decrease in potential energy of the bigger block. Of potential energy of the bigger block decreases, and potential energy we have already written mgh. That means its mass is 2m, g is g, known to everybody, and what is the displacement is 2 by is equal to 4 m gets cancelled is equal to 4g. Similarly, increase of potential energy of the smaller block is its mass into g into displacement 2 by m. So it is equal to 2g. So there is a decrease. This is the decrease and this is the increase. Now they want to know, find the decrease in the potential energy. Look, find. They wanted us to decrease. So net decrease in potential energy is 4g minus 2g. 4g minus 2g equal to 2g Newton. So this is your answer. Fine. It was not very difficult question. Let's go. We shall take the next question also. Once again, this question is simple question, but you have to always understand the question properly. Numerics are not very difficult. This question says that the system shown in the figure is released from rest, and a block of mass 1 kg is found to have a speed of 0.3 meter per second. The block of mass 1 kg, which block? This. So this has got a speed, velocity is equal to 0.3 meter per second. After it has descended through a distance of after it has descended, that means from here, it has descended by 1 meter. After it has descended, its velocity 0.3. Find the coefficient of friction here. What is the coefficient of friction here? That they want to know. Now, you have seen earlier also in this kind of a problem, is first it is to decide the motion and tension. For example, this is a single string, So tension here also will be T, tension here also will be T, tension here also will be T. But tension here will be 2T. Because this is there are twice T, tension is there twice in two strings. Here there is one string which is 2T. Second thing that you have to decide that what is if the velocity of this is 0.3, then what is the velocity of this block? Here, since there are two such strings and there is one string here, and there is a loop here, if this velocity is 0.3, whatever, if its acceleration is A If its acceleration is a, its acceleration will be. Similarly, if it displaces by a distance x, this will displace by a distance 2x. So some of you, if you find it little difficult to understand this, I can give you a clue. Suppose this is the original condition of the string, right? Say this is L1, this is L2, this is L3. Now suppose this block moves here by a distance of x. That means new condition is like this. This is L1 minus x, right? And this distance you do not know. You do not know. Now, what was the difference between these two? Say this is L2 plus y. Say this is L3 plus y. Now, total this length of this rope here and total length of the rope here is same. If you do this with a little bit rearrangement in the equation form, you will find x is equal to 2y. Similarly, that means if the displacement here is, say, 10 centimeter, displacement here will be 20 centimeter. If the acceleration here is a, acceleration here will be 2a. This is the first understanding all of you have to make it very clear. And if there are, of course, I have not found such problem sums in your textbook. If there are many loops in a Atwood machine, then you have to always use this information or technique how to find out the displacement of various parts of the Atwood machine. Anyway, let's come to the problem. Find the coefficient of friction. This coefficient of friction they want. In this kind of problems, you always draw the free body diagram. You always draw the free body diagram. Let us talk about the bigger block. Consider free body diagram of 4 kg block. Consider the free body diagram, bigger block. The bigger block, it has, the problem says it has moved by a distance of how much? 1 meter. Sorry, the smaller block has moved by a distance of 1 meter. So let us write it for your memory. Smaller block by 1 meter. So bigger block, if you write it down, you will not forget. Bigger block by 2 meters. That is most important. It moves by 2 meters. Right? Now, it has moved 2 meters. Now, let us find out what is its final velocity. It says that mass of 1 kg, the mass of 1 kg is found to have a velocity of 0.3 meter. So bigger block moves by 0.3 meter and attains velocity is equal to 0.3 multiplied by 2 equal to 0.6 meter per second. This was the actual trick in this question. So here, the final velocity we write V square, we use the equation V square equal to U square plus 2AS. From here, we write 0.6 whole square. Initial velocity was 0 into 2. S is distance it has moved is 2 meter. 2 meter. Therefore, A is equal to 0.6 whole square by 4 is equal to 0.36 by 4 is equal to 0 per second square. So we have found the value of the acceleration, a very important. Once you found the value of the acceleration, now you put your focus on the smaller 1 kg. Put your focus on the smaller 1 kg block. Or you can finally solve the problem of friction from here also. Let us draw the free body. This was the kinetic diagram of the bigger block. It moves by 2 kg and attains a velocity 0.6. Now we draw the free body diagram of the bigger block also. This bigger block here, there is a tension of 2T, right? And this bigger block has a tension of 2T and it has a weight of 4 kg. So there is a reaction of 4 mg. So frictional force is mu 4. Frictional force is mu 4 mg. It also says that the system in the figure is only one found to speed of 3 after it has descended by 1 meter, right? Now, so I do one thing here. I continue with this block for the 1 kg block, considering the 1 kg block. What you find 2T, 2 tension, because tension here is T, here is also tension T. 2T is equal to 1 kg into G. 2T is equal to G. From here, we find T is equal to G by 2, T is equal to G by 2, and G is considered 10 Newton per meter square is equal to 5. So tension T is equal to 5. This value we got. Now this value of tension T we shall use here. So here the tension is not 2T. I am sorry, I have written it wrongly. Here the tension is only T. Here the tension is only T. So if we consider the force in this horizontal direction, all the forces in this direction, what you find that 5 Newton, this T is equal to 5, or let us first write T minus 4 mg, mu 4 m. This also is wrong, not mu 4 mg. 4 is the answer. There should not be any m, because m is itself 4. This is 4g. This is also 4g. It is not 4 mg, rather 4g. This is 4G. Okay. Now, so tension. So this equation is now T minus 4G. T minus 4G is equal to mass into is 4 multiplied by acceleration has been found 0.09. 0.09. The value of T also has been obtained. It is 5. So therefore, 5 minus 4G, consider G is equal to 9.8. If you consider G is equal to 9.4, G is 4G is 39.2 mu equal to 0.36. From here, if you calculate, you will find mu is equal to, I should say approximately equal to, because 0.0.12. It is actual value by your calculator will show 0.118. So this is how you find out the, I repeat the whole problem once again so that you don't have any doubt anywhere. Firstly, in this kind of a machine, you will always know the displacement of acceleration here will be half of the displacement of acceleration. This is the first decision. But tension in the whole rope is set. And since it is given that it attains a velocity of 0.3, so this attains a velocity of 0.6. And it also says this moves by a distance of 1 meter, so the bigger one moves by a distance of 2 meters. From here, using the basic kinematic equation, we find out the value of acceleration. Fine. Then considering the tension diagram here, vertical force diagram here, 2T is equal to mass 1 kg into G. From here, we find G is tension T equal to 5. Then we go back to the free body horizontal force diagram with the bigger mass. Tension T is 5 and acceleration in this direction is 0.09. But there is a frictional force in backward direction is mu 4G. From this, you can easily find out mu is equal to 2.118. You can surely say it is equal to 0.12. Fine? So, in our next class, we shall take the next problem.